In this video, we're going to look at scatter plots. And so a scatter plot is something that you use to, in a sense, organize the data in a correlation study. It's kind of a way of making a graph that shows the relationships between variables. So this is the example we used in Chapter 1 where we talked about correlation studies. This was a researcher that looked at the number of hours worked per week and the student's grade point average. And he noticed as the number of hours that they work increased, it looks like in general the grade point average goes down. Okay. So I'm going to graph this here. Let me put the data here. So this is scatter plots. And the data, this is hours worked and GPA. So we got 4 hours, 3.78. And then 12 hours, 3.05. 20 hours, 3.19. 28 hours, 2.56, and 41 hours, 2.09. Okay, so that's our data. And so what a scatter plot does is it treats these like ordered pairs. Like these are the x coordinates, these are the y coordinates, and then it just plots the points here on kind of an XY axis, except instead of XY, this axis is hours worked, and this axis is GPA. So let's see, I'm going to go 5, 10, 15, 20, 25, 30, 35, 40. Maybe I'll do 10, 20, 30, 40. And then the GPA maybe 1.0, 2.0, 3.0, 4.0. And these don't have to be perfect, but you just put them in, approximate them. So like 4, 3.78. So 4 would be like right here. 3.78 for my y coordinate would be up here. So something like that. And you would put a point. So in other words, this is like x, this is like y, that's your x coordinate, y coordinate. So you go over to 4, up to 3.78 and put a point. Then 12, 3.05. So 12 would be like right here, 3.05 maybe right here. Okay, so 20, 3.19. So 20, then it actually goes up a little bit here to 3.19. 28 and 2.56. So 28, 2.56, maybe about right here. Not perfect, but good enough. And 41, way over here, 2.09. I don't know. So maybe something like this. Something like that. Okay, so you're going to plot all the points. And you could have a whole bunch of points here. But what you see here is that in general, there's kind of like this downward trend. As the number of hours worked increases, this grade point average is going down. And what we would say is that there's a negative correlation. And I would say that this is a pretty strong negative correlation. So the closer these lie along some line, the stronger the correlation is. Okay, so if I had an ordered set like this, this would be negative correlation, but it's not going to be nearly as strong. Okay, so in general, these are, there's a downward trend to the data, but this would be a fairly weak negative correlation. Okay, so a positive correlation would be as your x increases, your y also increases. So maybe a strong, this would be kind of a strong positive correlation. So you could say that this is a strong negative correlation. This is a weak negative correlation. And this would be a fairly strong positive correlation. Okay, so if these were spread out more and they didn't lie on a line, then it would be a kind of a weak positive correlation. And then you could have a situation where if I were to ask you if it were positive or negative, you wouldn't necessarily know. So maybe something like this. You know, it's kind of scattered out. And in this case, we would say that there's no correlation. It's pretty random. Okay, so you have weak negative correlation, or you have negative correlation, positive correlation. The closer they lie on a line, the stronger the correlation. If they're scattered quite a bit, then the correlation's weaker. If they're completely scattered, so you can't even really tell if it's positive or negative, then we would say that there's no correlation between the two variables. And so that is the idea behind scatter plots.